Hi guys, David.
Hey, dummy.
Hi.
Hi.
Hi, Safai. Can you hear me, David?
Yeah, I can hear you.
Okay.
Let me get my.
Just wait about a couple of minutes. I'm thinking we should just wait maybe like a couple of seconds and see if the other guys are going to join us. Or what do you think?
That sounds good.
Okay. So how has it been, David? Assignment.
It's been good. I haven't started assignment 3 yet. I did assignment 2, and I'm like catching up with lectures right now.
Okay. Well, I mean, the whole thing looks promising for you, right?
Yeah, it's going like a little quick, but it's all like stuff that like if I sit down, I can kind of like grasp like the concepts and everything. Seems pretty straightforward.
Okay. That's cool. So, I mean, you're ready to get employed as a Python engineer by the end of the year, right?
Yeah, hopefully we'll see. You know.
Yeah, I mean, that's the main goal, right? Or you just want to do it all hobby purposes.
Yeah, I mean like cuz I'm in what do you call it, the Bay Area. So like it's like big on like tech, you know?
Mm-hmm. Yeah.
So maybe something along those lines, like get into tech, you know Python and everything.
Yeah, definitely. There's really much you could do with it. So, I mean, do you have a particular area you streamline towards, or you're thinking towards maybe machine learning, web development, or which of them?
I'm sorry, what was that?
I mean, like, do you have a particular area you're trying to like learn towards, maybe machine learning, web development, or you know, whichever one?
I haven't really. I heard like a little bit about it. I don't really know too much. But I think that's like the way of the future. Definitely. I mean, definitely in the right, place to live for that kind of stuff.
Mm-hmm. Yeah. So I guess that's it. All right. Well done, David. Reina, welcome.
Hi, sorry I'm late.
How are you?
I'm doing well, thank you. How are you?
I'm very well too. How have your assignments been and everything, like the whole thing?
I haven't started assignment 3 yet, but I have been keeping up with the lectures.
Okay. You having any issues you might want us to like treat together in this section?
Nothing in particular, no.
Yeah, okay, that's all right. Sapphire, you're mute. I can't hear you. I was beckoning the other time, but I couldn't hear you. Sapphire?
I can hear you well. Yes.
Oh, okay. Guess you can hear us then. Okay, so let's just let's go into what we have for today.
Okay.
Okay, so this is our 4th week, and then we're gonna be having one more meeting together, and I guess we should have some other maybe after the next meeting we should have some other way we could always communicate, even if it's just by text, if we're not really meeting over Zoom anymore. I think that's all right. Yeah.
Yeah, that works.
Yeah. Okay. So I'm just going to be going over images just to like refresh our memory on the other videos we've seen and materials we've seen earlier. So like basically images are made up of units called pixels, and you see each of those pixels, they have x and y coordinates that represent their location in the image. So, and then you see these pixels, they have single color each. And then, you know, this single color is always encoded as a 3-number unit in the order red, green, and blue. So with 255 being the highest value that each of those numbers can be. So for example, if we have a color, a pixel with color 10, 243, and 39, you're able to what's it, decode from here that the shade of red is about 10 out of 255, and then green is 243 out of 255, and then 39, that's for blue, out of 255. So these numbers represent the intensity of the colors represented in that position in the color code. So we can always tell from this example that this color is going to be very greenish because the green has the highest value. So also, I think it's important to note that all these numbers can be combined in different values to make up any kind of color, you know, whatever you want to think of, red, burgundy, yellow, green. I mean, you could always combine these numbers to make those colors. So just like a graphical illustration of this, looking at this image, we have the image rows, we have the image columns. So this is an image. Let's just assume this is an image. And then we have on the rows, we have A, B, C, D, E, which when we are representing this or when we want to access this in the computer, we'll be accessing this with 1, 2, 3, 4, 5. And then the columns also, we have 1, 2, 3, 4, 5, 6, 7, 8 from left to right, and then the rows from top to the bottom. So, and then if we want to access, for example, this part of the image, this pixel of the image, we are going to be accessing it by checking the row which it falls and then the column which it falls. So, for example, this particular one falls on the first row, that's row 1, and then the other one is column 5. So we know that the position of this pixel is going to be 2, 5. Like it's 2 on the x-axis. I'm sorry, 1, 5 rather. It's 1 on the x-axis and then 5 on the y-axis. Do we understand?
Wait, isn't like for X, isn't it horizontal, and then for Y it's like vertical, so it's like if the top left corner is 0, 0, wouldn't it be 5, 1 for this?
Sorry, I didn't get you.
So as well.
Wouldn't it be 5, 1 because you're going 5 horizontally and then 1 down?
Okay, so basically the idea is to pick rows first and then columns second. Do you get? So at the end of the day, I feel like the order doesn't really matter depending on how you are coding yours or how you're representing your values. But the idea is having your rows first in the coordinates. Do you get it? So the rows should be first in the coordinates. So if I'm going to be getting the coordinates of this black, which black pixel I have my arrow over, I'm going to be picking the row first. This is row 1, this is row 2, and then this is column 5. That's going to be 2, 5. Do you get that now, Reina? Okay, so just to summarize the whole thing before we go to our problems, there are two ways to access an image pixel, like with the simple image library we are using for all these exercises. And the first one is like a for each loop, which goes over the pixels from left to right, then top to bottom. So the first one, when you loop over each pixel, like you just say for pixel in this image, it simply goes from this to 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 this. Then once it reaches the end of the image, it goes to the next row and starts at the beginning of the first column on the next row, and then goes all the way to the end, then comes to the beginning again, goes all the way to the end till it reaches the last column on the last row of the image. So that's the first way. And then the second way is to have nested loops. And so the nested loop, the way it's going to work is, first of all, we have a loop that goes over these rows. Then you have a loop that says for let me say y in okay, so I think that's where Rena's confusion came in. So right now we could just say, because we represented x with rows and then we represented columns with y. So I think Rena feels it should be x here, then y here, then it should be less confusing, right? So let's do that. I think that was an oversight for me too. So if we have that way, we could always go over the rows first and say for y in the rows we have in the image, and we know apparently the rows of the image are equivalent to the height of the image. So if we have an image of 200 pixels height, then we know that we're going to be having about 200 rows in that image. And then if it's 200 by maybe 200, so we know we are going to be having 200 columns also in that image. So for the nested loop, we know that we have to iterate over every row. Then while we're iterating over each row, we iterate over every column that is in the row. Do you understand? Okay, so that's for the accessing the image pixel. So, and then the difference between the both of them is that when you iterate with the first method, which is looping over everything, like one after the other, going over each row and then going to the next row automatically, and then going over its columns, going to the next row, we do not need values for x and y. That's the only reason why we would use the first method. But in a situation where we need the values for x and y, like for a certain problem which we'll be addressing, I think if we have time, we will be using the nested because we need the values, the coordinates for each of the pixels. So secondly, you can edit a pixel by updating its property. So, and you remember that only the color properties of the pixel can be changed. The coordinates cannot be changed. For example, if you want to change like this pixel to blue, you could just do pixel, maybe after using the first for loop method. And then by the time you get to this pixel, you could say pixel dot blue is equals to 255. Maybe just set it to the highest value of blue it could always have. And then for the last one, you could also access the height and the width of the image by the properties height and width. So if you just say image is equals to height, image dot height, then to get the width, you say image dot width. So enough of the talking. So let's just go into the first problem which we are going to be addressing today. And what we are going to be achieving with this problem is we're going to be transforming this image to the second one. So, I mean, do we see any difference in the images? Just to be sure.
The second image is like more, it's like brighter. Let me see.
Yeah, not really better, but we just have a kind of filter over it, and then some part of it seems gray, like a gray scale stuff. So let me just open the problem in text. So let me try to zoom in. So this filter heavily uses the idea of a pixel average. So the pixel average for a pixel, we say its pixel average is the average of its red, green, and blue components. So going back to this our image, what we want to do here is once we go over every pixel in this image, for example, we are on the first one, we want to check that, we want to check the average of the colors. So we know that for sure, every pixel has a value of red, they have a value of green, and they have a value of blue, right? So we want to check the average of these three values, and then we check if that average is up to a certain threshold. If it's up to a certain threshold, then we assign our new values to the old value, to the assign our average value to the old values rather. But then if it's not, we leave the color as it is. So let's just read what we have here. For a pixel, we say its pixel average is the average of its red, green, and blue components. To apply this filter for each pixel, if the pixel is bright, so this is the condition which we are checking in our for loop. If the pixel is bright, then you should make it grayscale. We consider a pixel to be bright if the pixel average is greater than 153. So that's the threshold which we are checking for our average. So for this problem, to make a pixel gray, we are going to set each of its red, green, and blue channel to be equal to the average. And then if the pixel is not bright, you should leave it the same color. So let's just get to our code. So right now, I believe we have access to this code, this boilerplate code, like the default setup for the problem. Do we? So by just running this program, the default one, what we have is the old image. So we want to be able to transform this image to the other one by just simply following the steps we have right there. So, I mean, before we go into this, does anybody have an idea what we should do next with this problem?
I think you could use for like the for loop for pixel and image, and then you can do an if statement with and then like you you set a variable equal to the average, and then you first find the average of the red, green, and blue in the pixel.
Yeah, exactly. So let's do that right in this block. So we're supposed to do that in here. So once I iterate over the pixels of the image, and from our slides the other time, we got that we could just do a for loop over the image to iterate over the pixels. So for pixel in image, then we run our block in here. And what we want to do next is to check that the color, the average of the colors of that pixel is not greater than 153. So let's just call a variable, let's define a variable here and call it pixel threshold. And assign 153. So then what we want to do right now is to check the average of the pixel. Then we do, to check an average, definitely we know that we are going to be running, adding those three values together and then dividing it by 3. So let's just get the average and say pixel dot red. We could access the red value of that pixel by just doing pixel dot red plus pixel dot blue RGB. So that should be green next, but we could do it in any other, but just to be clear, dot then blue as the last one. So what we want to do is to add this together and divide it by 3. So I'm just going to put this in parentheses, then divided by 3. So contrary to the original division sign we are used to, we are going to be doing something a bit different by using a double slash. Do we know this? Like, do we have an idea of what this does?
It gives you an integer, it truncates any decimal.
Exactly. So it truncates the decimal places and gives you an integer. So rather than giving us a float as the result, it will be giving us an integer as the result of the value of the addition, rather. So once we have the average, what we want to do next is to check that our average, if average is greater than one threshold, we already set that, so let's just call that straight. If it's greater than threshold, we want to change those values to the average like we have here. We consider a pixel to be bright if the pixel average is greater than 153. So if the pixel is bright, then we should make it grayscale. How do we make it grayscale? We assign the average value we got to each of those colors. So we say pixel the red is equals to average, pixel the blue, green, I'll use in blue first, is equals to average, pixel the blue is equals to average. So okay, so I think we're on the right path. So for this problem to make a pixel gray, this. So let's just try to run this program. Let's see what it does. Okay, so I hope we can see the change from the Zoom video call, because I think the resolutions are always quite lower than normal. So we see that the bright sides are made gray, like they're just converted to gray colors, like the average of individual pixels in that area. So let's try this on another image. I think I have a couple of images here. Let's do image 2. Okay, so this is not as conspicuous as the first one, but we can see the floor, the runway, left and right. We see that part of them are changed to gray, and then even the line, part of the line is also changed to gray. So that's pretty much everything about this problem. Do you have any questions about this first problem? David?
Looks good.
Okay, so 5.
It was okay, thanks.
Okay. So let's go to the next one, which is of course trimming. What we want to do here is to crop. I think we all know this feature as cropping now, photo editing applications and every one of them. So what we want to do here is to write our own program to crop our own images. Really, this is what works on the back end of all these mobile apps and all our photo editing softwares. And the only difference is that we won't be adding the part that lets us just drag our fingers across or just drag our mouse across the image for it to specify this parts to this parts. These are the parts we need from this image. And basically after dragging those things across, or sliding your fingers across your screen to select the part you want, at the end of the day, it's still a function that runs behind that says, okay, this user dragged from pixel 2, 100 up to pixel 100, 299. So the program still does the same thing and then outputs the image to you. Hey, this is the result of the crop operation you did. So what we want to do here is to write a function that crops the image. So the function returns a simple image, which is a trimmed and cropped version of the original image by shaving trim size pixels. So that trim size is a parameter which we pass into the function, and then it's going to be in pixels from each side. So it's going to be representing the amount of pixels we'll be shaving off each side of the image. So if we are going to be passing 20 into this function, we know we are going to be removing 20 pixels from the top of the image, from the bottom of the image, 20 pixels from the left of the image, and 20 pixels from the right side of the image also. Then we end up with something like this. So for this particular example, this one was passed in 30 pixels. So it ended up with an image like this. So let's go straight to our IDE so we can run our own program. And that's trim crop. So let's just delete all these comments. We don't need all these comments we have here. We already have the reference on what to do. So firstly, what we are going to be doing with this problem is to get the new width and new height of our new image. So we are going to do new width, or let's get the old width first. Let's just get that old width of the image. That's the original image. Do we understand this part? This image was initialized here, then it was passed in this function. This is the function we are trying to work on right now. Do you understand this part, or do I just go over from the start?
Yes.
Okay. Reina, David?
Yeah, looks good.
Okay. Okay. So our old width will be the original width, original image, that's which was passed from this main function, dot width. Then we say new width is equals to original width plus height, sorry, old height. Original image plus height. So to get a new image width and a new image height, we know definitely our new image is going to be smaller than the original image because we are cropping certain parts out of the old image. So we're going to be ending up with an image that is about, if we are trimming 30 pixels from the left, top, bottom, and right, we are going to be ending up with an image that is 60 pixels less higher than the initial, and then 60 pixels less wider than the initial. So what I mean by that is left and right, we are taking 30 pixels. So we are going to be taking off 60 pixels from the width in total. And then also from the height, we are going to be taking 60 pixels from the height in total. So we could just say our new width is equals to old width minus, we're doing 2 times old, 2 times trim size. Do you understand that part? Since we are taking for, okay, Reina.
How do you know where it's going to trim from? Like, how do you know it's gonna get like 30 from the top and 30 from the bottom?
Okay, so the problem right now is generic. We have a trim size that is passed in the function, and then what the trim size will do according to what was given here, is that whatever trim size we are given, we take off every side of the image. Do you understand?
Yeah.
So we are not really given that you trim from the top, from the bottom, from the left, or from the right. You are taking from every side of the image. So we are going to, for the width, since we are going to be taking from the left and right, and they are going to be the same thing, we are going to be taking from the left and right, we will multiply 2 by the trim width to remove from the old width for us to be able to get the new width of the image we want to output to the user. Is that clear?
Yes.
Okay. So, okay, we got 10 minutes more. And then, so the new height is equals to old height minus 2 times trim size. We're literally doing the same thing for the old size or for the old height also. So to get, we are going to be initializing a blank image where we want to copy the pixels that the user selected that they want. So I mean, we are just illustrating this in sense that the user selected some pixels and some selected a particular portion, and the portion they selected has 30 pixels above, which they do not want, 30 pixels on the left, which they do not want, 30 pixels on the right, which they do not want, and then 30 pixels beneath, which they do not want. Do we understand this? Okay. Now, I mean, if we could always do something a bit practical, so we could. So this is what we are just trying to illustrate. Let's use the crop function in here. This is what we did. We drew this, and then this is the portion we want. That was why we selected this part. So we are trying to trim out this part, this part, this part, and this part. And we know the new image we are going to be getting is going to be of size of this selected part. So what we want to do right now is to create a blank image of this size, and then we copy every of these pixels of the selected part into the new image which we created, the blank image which we created, leaving out all these surrounding parts. So basically that's what we want to do. So we said new image, and this is how to implement a new image.blank. Then we say new width. That's the first parameter it takes. And then the height is the parameter, second parameter it takes. So passing the new width and the new height. So what we want to do right now is to iterate over this new image, each pixel of the image, so we can get value from the old image and then copy it over to the new image. But the issue is knowing exactly where to copy in the old image, since we are going to be throwing away 30 from the left, 30 from the right. Actually, right now, we are not even like hard coding 30, but we know we are throwing away trim size from the left, trim size from the right, top, bottom. So we're going to say, okay, this is another part I need to note. We're going to be using the second iteration method of looping through the pixels of the image, since we are going to be needing the coordinates of the pixels. So first of all, we do for y in, so that's the row. Y signifies the row. For y in the new image dot height range, new image dot height. Then once we are on the first, for every row on this image, we want to go through its columns too. So we are going to iterate over every column and then say for x in range of new image dot width. So right now we can access y, we can access x. Do you understand? Okay, so while we have this loop, what we want to do right now is to go over to the old image and copy our value from each and every one of those pixels we are needing in here. So I'm going to say old the pixel which we want is equals to old image, original image dot get pixel. We are going to be getting x and then the y part of it. So we have x, we have y already. Do you understand? Okay. So right now we have the pixel, but the thing is our 0,0 in the new image is different from the 0,0 in the old image, right? Because here we already created an image of this size, but then if we pick the first pixel in this old image is going to be equivalent to the first pixel here in the old image, or new image rather, will be equivalent to pixel 00 in this old image. It will be right here. So we'll be copying here, which we do not need. So we want to copy this area. So that means we are going to be adding a 30 pixel, or let me say the trim size, to the coordinates which we have. You understand? Okay, let's just do this so we could get that very well. So right now we have the pixel of this, and then we are not trying to get this x exactly or y exactly. We want to get plus trim size plus trim size, right? Okay, so if we have that, we want to do new image dot set pixel and then x, y, and then it takes the last parameter pixel. So let's run this program now and then see where we have to make our changes next. Oh, sorry. I did that when I was playing around with the program. Non-type has no attribute show. Okay, we are not returning the image. We should return the image from our function. So when we don't return anything, it automatically returns none from whichever function we are not returning anything from. So we are going to be returning our new image. So let's run this now. So we see the output of this, right?
Mhm.
So it already crops 30 from here, 30 from here, 30 from here, 30 from here. So if we try this on, let's try this on this our particular image 1, and then image 1. What's the extension? I think it's JPG. It's a JPEG image. So we see for this particular image, it's cropped out a certain part of it, also left, right, bottom, and then what other parts? Left, right, bottom, top. Okay, so that's it about cropping images. I think the last part is adding a border to the image, like you're adding a border from the to the left, top, bottom. I mean, there's pretty much was it so many things you could do just to practicalize manipulating these images. You could just maybe come up with writing on your own image, maybe putting your own name on the image through the program. I mean, you could just do anything at all. So we have less than a minute left. Is there any question like I should answer very, very quickly? Safai, David, Reina, and then Fumlayo.
I'm good.
It looks good, yeah.
Yeah,
Good.
okay. So do we need this also? I mean, do I send this over? Like,
Yes.
Yeah.
okay. So I'll put it in the summary as usual, so we could always like gain access to it. And then also I feel we are pretty okay with the 40 minutes we made use of, we had today. So we might not really need to think of getting another platform like I thought earlier. So the only thing we will be planning on, maybe it's going to be in the final class, and that will be the platform which we are going to be using for like further discussions after the final class. So, and I mean, towards that time, we could always like get suggestions and then have something in mind we would like to suggest. So, so I think that's it for today. And thank you all for coming. I really appreciate it. Like